So, back to it early, surprise senior meeting. It says find all the zeros. It says look at the graph to find the real one, or just set it equal to 0 and hit it with synthetic division. So the reason it's talking about setting it equal to 0 is because, well, there's shortcuts to it. But anyways, if you just look at the graph of this thing, you'll be able to get the real 0. I haven't done that with you in class because I wanted you to suffer and remember how things are done by hand. I didn't do that because I was mean, because some of you will be more likely to remember now because you went through the struggle of doing it by hand, that maybe you'll remember how important a graphing calculator is. Anyway, Zoom 6. So look at the graph to find the real one. So from the graph, I see a real 0. I hope you do too. All right, so from the graph, there is a real 0 at x equals -2. So now we're just going to do synthetic division and get rid of it. Coefficients, I think that was 1. I've blocked it. That was a 1. 1, 2, 9, 18. Your acronym for synthetic division again, DMA, drop, multiply, and add. -2 times 1 is -2. 2 plus -2 is 0. -2 times 0 is 0. 9 plus 0 is 9. -2 times 9 is -18. And we get a 0. So for those of you who are a little thick-headed, remainder constant xx squared, we are left with x squared plus 9 equals 0. You could QF. I mean, A would be 1, C is 9, B is 0. You could. Or you just move that 9 over. Right? That makes it x squared equals -9. The opposite of squaring is square rooting. Don't forget your plus or minus symbol. You know it's imaginary, right? And you know that the root of 9 is 3. At least you're supposed to. Sadly, I don't know how it came to be, but a lot of kids don't know what the square root of 9 is, but it's 3. So our zeros were -2, 3i, and -3i. And by the way, these two guys are conjugates. They are conjugates of each other. It's a nice, important word. Polynomial has 4 known zeros, -1, 5, √2 minus 1, and 5 minus 3i. What are its remaining zeros, and what degree is the polynomial? So we have a theorem here. It's called a conjugate theorem. And it says, there's 2 of them. There's one based on irrational roots and imaginary and complex numbers. But for complex numbers, it's pretty simple. If a plus bi is a 0, comma, then a minus bi is also a 0. Then you have the one on irrational numbers, which is your square roots of weird things, cubic roots of weird things, and so forth. And it's usually if a plus, I wish I could type in a symbolism here. I'll just draw it in. But if a plus a root of b is a 0, then a minus root of b is a 0. So here's the thing. Weird zeros have conjugates. So these two guys are not weird. They don't have conjugates. These two guys, these are weird. And I want you to pay attention. It's always the weird thing that changes sign. bi change sign, root b change sign. The weird piece changes sign. So I have root 2 minus 1. Another 0 is going to be negative root 2 minus 1. It's only the weird piece that changes sign. I also have 5 minus 3, so the other one has to be 5 plus 3i because it's the weird piece that changes sign. Now, the degree of the polynomial, we have 1, 2, 3, 4, 5, 6 zeros. Okay? There are 6 zeros, which means by the fundamental theorem of algebra, we must be at least x to the 6th. Now, that's actually at least. But we're at least x to the 6th. Because there might have been more, but it's x to the 6th. What was the relationship between those two given zeros and their counterparts? They were conjugates of each other. Conjugates. Word of the day. How many zeros, real or imaginary, does the polynomial 5x to the 8th minus 13x to the 4th, blah, blah, blah? What's really, really sad is about 1 in 5 students will miss this question. Blind copiers. So, the fundamental theorem of algebra and its corollaries basically states that x to the n has exactly n zeros. All right? Now, this x to the n is the power function. Okay? And the power function is the first term in standard form. So the only thing I will look at is this guy right here. So I am looking entirely at 5x to the 108th. I'm not paying a lick of attention to anything else. 5x to the 108 has 108 zeros. Several of them might happen more than once. Some of them are real, all of them are not. Real or complex. But that's the main thing. 108 zeros. 108. Such an easy question. It's going to be missed by so many kids. 12 is kind of scary. Determine the power function, the zeros, including their multiplicity, and then classify the zero as a touch, across, or imaginary. So the power function here is going to have 4x squared. This piece is going to have x cubed, x and 2x. And that's to the 4th. And sorry, it's not 2x to the 4th. Let me do this. And then x squared squared. All right, so 2x to the 4th is going to be 16x to the 4th. X squared squared is x to the 4th. Now let's see, what do I have so far with this? That's 4x to the 6th, I think. 2 times 2 plus 3 plus 1, that's 6. All right, let's do some more multiplication. 4 times 16 is 64. 6 plus 4 is 10, plus 4 is 14. 64x to the 14th. It's quite a bit. Now, by the way, when I add all these multiplicities up, it better be 14. I should have 14 zeros. All right, the first zero comes from using the zero product property. So by ZPP, 4x squared is 0. And the only way this possibly becomes true is if x is 0. If you don't understand that, you need to think about it. Because isn't 4 times a 0 squared equal to 0? So one of my zeros is x equals 0. The exponent was 2, so that's my multiplicity. Just take that exponent, there's your multiplicity. And now your notes about even multiplicity. Even multiplicity touches the x-axis. And by God, 2 is even. That's a touch. My next 0 is created by this factor x minus 1. And it's just a simple run over x is 1, change sign. The multiplicity comes from the exponents of 3. And 3 is odd. Odd multiplicity crosses the x-axis. That's a cross. 0, 3 happens at this factor. 2x minus 1 is a nothing. Add 1. Divide by 2. X is a half. The exponent is 4. Again, 4 is even. And evens touch. 0, 4. I wonder why I left so many blanks here. 1, 2, 3, 4, 5. I don't know why I have so many blanks. You don't need the 6th one, apparently. Oh, I skipped a factor, didn't I? What happened to that guy? I kind of missed that guy. Let's move this one on down. I completely skipped over x plus 2. See that guy right there? X plus 2 is nothing. X is negative 2. It has an understood exponent of 1, and that's going to get some kids, because, man, some of us, I don't know that we know how to tie our shoes yet, but we have the understood exponent of 1, which is odd. That's a crossing. Odds cross, evens touch. All right. So now I'm at this last factor, and there's a reason we have 0, 5, and 6. The last factor says that x squared plus 1 is a nothing. We move the 1 over, and x squared is negative 1. You know, I've been giving you formula quizzes. You are supposed to memorize. The root of negative 1 is I. 2 solutions, plus or minus I. So we have a 0 at I and a 0 at negative I. They both happen one time. Even though they're imaginary, they still happen. But they're both imaginary. So let's take a look at our numbers here. We're supposed to get a 14. Oh, no. They both happen twice. Multiplicity is right there. 2. So 2 and 3 makes 5. Plus 1 is 6. Plus 4 is 10. 12, 14. Just like it said. 14. All right, the graph of a polynomial has 129 turning points. What is the least degree the polynomial should be? So here's an example of an x cubed. A typical x cubed will look something like this. Not mom. Okay, this is not mom. I want to make sure you know that. And it has 2 turning points. But the exponent was 3. So the rule on turning points is that the least degree, least, is the number of turning points plus 1. The actual theorem says x to the n has at most n minus 1 turning points. So if I have 129 turning points, I am at least 129 plus 1, which is 130. I am at least x to the 130th power. At the very, very minimum, that's what I am. Below is a graph of f of x. Write the equation of f of x in factored form. And there's a lot more to this. This is a multi-part question. It is. So one of the things will be like end behavior based on, end behavior is kind of where it is. Like, how is this thing behaving? It's starting high and it's ending low. So what does that mean? Well, that means it's at least a negative x to the odd. That's what it means. I didn't give you the full graph, but you should kind of know that if this thing goes down, eventually it's going to come back up, right? So another part of this one is number of turning points. Well, she has 1, 2, 3, 4. She has 4 turning points. By the way, if you're wondering why is Milbrath adding all this stuff, this is a multi-part question on the test, and these are the parts that are in it. All right, so then we have the degree of the polynomial based on the number of turning points. So the deal is it's x raised to the number of turning points plus 1. So this is x to the 4 plus 1, which is x to the 5th. So I expect a 5th degree polynomial. Is there anything else in that one? At some point in time, you have to list the zeros. I can't remember if you're listing the zeros under multiplicity or not. Probably is. State the zeros and their multiplicity. So we have x equals -3. That's coming from this guy right here. It's right there. This is a cross, which means it happens at least once. So you'd probably see m equals 1, m for multiplicity. There's 1 at -1. It is also crossing, so the multiplicity is 1. There's 1 right here where x is 0, and it's a touch, so the multiplicity is 2 because touches are even. And there's another one at 2, it's x equals 2, and it's crossing, so m is 1. Now, if you do 1 plus 1 plus 2 plus 1, you get 5. These should reinforce each other. All right, so we're at that point in time. Now what we're going to do is we're going to list the factors. Actually, no. Now what we're going to do is we're going to write the polynomial. All right? So let me clear this out. All right, the polynomial would be f of x equals, there's always an a. X equals -3 is a 0. The factor is x plus 3. X minus 1 is a 0. The factor is x plus 1. X equals 0 is a 0. The factor is x. And then we have x minus 2. Now, I need to talk about multiplicity. This was a cross. X plus 1 is a cross. X equals 0 is a touch. So it needs an exponent of 2. Because 1 plus 1 plus 2 plus 1 was 5, which we came up with earlier. All right, now how do we find a? Find a, use the y-intercept. Or can you? There's another point you need that I didn't give you. Bummer. It's going to be right up here. Been really cool if I would have given it to you, but I didn't. So it looks like it's going to be at roughly the 1.5, that's what I'm going to have to say, and probably 7. And we can't use the y-intercept because it's not there. So use the other point, which I never gave you, but we're going to say that it's at 1.5 comma 7. So a point gives you an x and a y. So x is 1.5 and y is 7. We're going to plug those things in. 7 equals a times 1.5 plus 3 times 1.5 plus 1 times 1.5 to the second times 1.5 minus 2. And we're going to crank out some math here. All right. So let's see what's attached to A. We've got first factor is 4.5. I know that much. Next one's 2.5. 1.5 squared should be 2.25, but who knows? I don't want to make any mistakes. And then we got negative 0.5. See if I can convert that to a fraction. And I can. Boy, this one's ugly. Don't worry, your test won't be that bad. Negative 405 over 32a. What we're going to do is we're just going to divide both sides by that negative 405 over 32. All right? So we have 7 divided by that dude. Play along. Negative 224 over 405. So A equals negative 224 over, I believe it was 405. 405. And now you can write your equation. All you got to do is take that little guy right there and stick him there. And again, the test will have nicer answers. I really don't spend a lot of time trying to create a twin. I'm not going to sit there and spend 3 or 4 minutes making a question look nice with easy numbers. But here's your actual equation, and traditionally this guy would go out front after the A. Negative 224 over 405 x squared. Then we have an x minus a 2, x plus 1, x plus 3. And order doesn't really matter. Don't think order matters. Order does not matter because it's all multiplied together. All right, moving forward. I just cannot believe that I did not give you a point on that. I need to check that real quick. That's chapter 3, twin, 24, 25. I probably should have used like 6.5 or something. I don't know. It should have worked out better, but it did not. 15, a polynomial has roots at x equals 0 and x minus root 5. What is the equation of the polynomial in STD form? So here's one of these weird, that should have an equal sign. That's a weird, no. Here's the problem. This needs to be fixed. 1 minus root 5. That's what I needed. Anyways, this guy is weird. So it has a conjugate. And the conjugate is 1 plus root 5. You know, I don't want to make this that hard. I don't want this to be a question that takes y'all too long. This is x equals negative root 5. Okay, that's what we're going to go to, which is still weird. So it has a conjugate of x equals positive root 5. Weird zeros have conjugates. That's a theorem. We get to assume that a is 1. So when we write our equation, we have x equals 0, which the factor would be x minus 0, which is just x. Here we have x equals negative root 5. The factor would be x plus root 5 because we change signs when we enter parentheses. And here we have negative, here we have positive root 5, so the factor would be x minus root 5. And then you just ask yourself, what would Jesus do? Jesus would FOIL all day long. And FOILing is not supposed to take you an eternity. X times x is x squared. X times the negative root 5 is negative root 5x, or negative x root 5, doesn't matter. That was first and outer. Here comes inner, plus x root 5. A radical times itself is the number inside. A positive times a negative is a negative. Still got the x out front, but let's clean up the inside here first. We have an x squared. These guys cancel. I don't even need that set of parentheses all the way over there. And now I just do the distributive property. X cubed minus 5x. So it looked like it might be hideous, but it was not hideous. At all was it hideous. Moving forward. Use your calculator to find the cubic function of best fit given the ordered pairs 3, 0, 5, 20, negative 2, 3, 6, 5, and so forth. And it's pretty simple. You're going to put your x's into list 1, your y's into list 2. Oh, I got to pause. Be right there.